Good morning everyone. Today I am going to teach about a combinational logic circuit. This is the first chapter in a digital electronics subject. In this combinational logic circuit chapter, today I am going to cover these following topics. First one is the demultiplexer applications, and then demultiplexer ICs and their features, and then last one is introduction to encoders and decoders. First one is demultiplexer applications. First one is a demultiplexer is used to connect a single source to multiple destinations. As you all know, the demux is having one input and multiple outputs. Depending upon the select line input is distributed to any one of the output. Because of this property of demux, we can control multiple destinations at one end by using single source. By using demultiplexer, it is used to connect a single source to multiple destinations. The next one is communication system. Demultiplexer are used in communication system. Mux is used to combine the signal and demux is used to separate the signal. Because of these two properties of mux and demux, we can use multiplexer and demultiplexer in communication system. Next one is arithmetic. Demultiplexer is used in arithmetic logical unit. In arithmetic logical unit, the output of ALU can be stored in multiple resistor or storage units with the help of demultiplexer. That means demultiplexer is used here as a storage unit. That means you can store data or output of ALU in the demultiplexer. Hence, we are using demultiplexer in the arithmetic logical unit. This is the third application of demultiplexer, and the next one is demultiplexer are used as a serial to parallel converter. See, here we are having one input and multiple outputs. Because of this block diagram, because of the block diagram of demultiplexer or the property of demultiplexer, it does serial to parallel conversion. Hence the demultiplexer application is serial to parallel converter. The next one is demultiplexers are used in security monitoring systems. In security monitoring systems also we are using demultiplexers. Demultiplexers are used in ATM packets broadcasting. If you want to broadcast some messages to customers, at that time this demultiplexer is used. Demultiplexers are used in ATM packet broadcasting. Next is demultiplexers are used in clock data recovery system. It is used in clock data recovery system. Next is they are also used in wavelength rotors. Wavelength rotors means different wavelength signals are routed to different ports. That is the meaning of a wavelength rotor. Different wavelength signals are routed to different ports. These are the applications of a next is demultiplexer ICs and their features. First one is 74139 IC. This is a dual 1:4 demultiplexer. Here the output is inverted input. That means it is a high speed dual 1:4 decoder or multiplexer. The device has two independent decoders here. It is having two independent decoders or demultiplexers, each accepting two inputs and providing four manually exclusive active low outputs. See here the output is active low output, hence the name output is inverted input. Okay. The next IC is 74156. This is also a dual 1:4 demultiplexer, but the output is open collector type. Here it is also a 74156 IC is a high speed dual 1:4 decoder or a demultiplexer. These devices have two decoders with common 2-bit address inputs, or it is having a two independent decoders or a demultiplexer in this IC, and the output is open collector type. That means an open collector is a common type of output that is found on many of the ICs, which behaves like a switch. that is either connected to ground or disconnected. Instead of outputting a signal of a specific voltage or current, the output signal is applied to the base of an internal NPN transistor. See here, the output is connected to the base of the NPN transistor whose collector is open, and the emitter terminal is grounded here. Hence we can call it as a output is open collector type. This is also a dual 1:4 demultiplexer, but the output is open collector type. Okay, next one is a 74138 IC. This IC is a 1:8 demultiplexer. The chip is designed for decoding or demultiplexing application. Here, this IC can be used for decoding as well as demultiplexing application, and it is having a 3 inputs to 8 output setup. It is having 3 inputs to 8 output setup. The design is also made for the chip to be used in high performance memory decoding or data routing applications. It is mainly used in data routing applications and high performance memory decoding applications. The next one is 74238 IC. This is also a 3 to 8 line decoder or a demultiplexer IC. This is an excellent chip to use to increase the output of a microcontroller. To increase the output of a microcontroller, this type of IC is used. That is 74238. The next one is 74154 IC. This is a 1:16 demultiplexer. Here the output is inverted input. That means the output is always a active low output. Hence we can call it as output is inverted input. See, 74154 IC, it is a 4-line 16-line demultiplexer or a decoder. Here this chip is often used in demultiplexing applications such as digital clocks, LED matrix and other graphical outputs. It is used in graphical outputs, it is used in LED matrices, and it is used in digital clocks. The next IC is 74159 IC. This is a 4-line to 16-line decoder or a demultiplexer with open collector output, and the input is same as and the output is same as input here. Here in all other ICs, output is inverted, but here the output is same as input. That means active high output. The output is active high, depending upon see, the next one is introduction to encoders and decoders. See, encoding is a process of converting familiar symbols or numbers to a coded format. That means we have a familiar number or which you can understand easily. That type of number is there. If you want to convert that into a coded format, then that process is called as encoding. Examples for encoders are octal to binary encoder. Octal to binary encoder is a one technique which converts familiar symbols or numbers into a coded format. Decimal to BCD encoder, this is also an example for encoder. And decimal to BCD priority encoder, this is also a type of encoder. Encoder is usually having 2:n input lines, 2:n input lines and n output lines. 2:n input lines and n output lines. Okay. The next one is decoder. The decoder converts coded information such as binary into a recognizable form such as decimal. That means in encoder is converting familiar symbol into coded format. The decoder converts reverse of that. That means coded format to a familiar symbol or a familiar number. That is nothing but decoder. The decoder converts coded information such as a binary into a recognizable form such as decimal. Examples of decoders are BCD to decimal decoder, next BCD to 7-sec 7 segment decoder. These are the examples for decoders. Decoders are having n input lines and 2 raised to n output lines. Encoder and a decoder both are, if encoder is doing one thing and the decoder is doing the reverse of the encoder. Similarly, in case of a multiplexer and demultiplexer, multiplexer is sending input to any one of the input is sent to output depending upon the select line input. In case of demultiplexer, any one of the depending upon the select line input, input is sent to or input is distributed to any one of the output. Demultiplexer does the reverse operation of multiplexer. Decoder does the reverse operation of encoder. This is how the encoder and decoders works and mux demux works. Okay, thank you.